Hello, advanced algebra class. We've had a couple questions regarding the word problems. I'm going to give you a couple problems that you've seen similar type problems to before, and we're going to build upon those to help you on the word problem. So let's get going. First off here, this is from a couple nights ago. It's from last week. Write an absolute value equation representing all the numbers that are 7 units away from 5. So let's draw a number line here really quick to get a visual of what's going on. Okay, so here is 5. What's 7 units to the right? It's 12, right? So 12. What's 7 units to the left? It's going to be -2, right? So those are all the numbers. It's only 2 of them. It's -2 and 12. This is not an inequality problem. It's an equation problem. So if you think about absolute value and the definition of absolute value, think about that to yourself. I'll pause for just a second. What is the definition of absolute value? It's a number's distance from what? From 0. So we're worried about the distance from 5. Well, how far is 5 from 0? 5 is 5 from 0. And we've got to go to the left to get to 0, right? 0 is about right there. And we go to the left 5. Now, is that the positive direction or the negative direction? That's the negative direction, right? Okay, so if I've got x, and I subtract 5 from it because I'm moving 5 to the left to get to 0. X minus 5. Okay, the absolute value of that is equal to, what's the distance, right? Because this is the absolute value. It's the distance a number is from 0. What is the distance we're dealing with? 7 units. So our distance is 7. Okay, so one more time. The way we did this was 12 and -2, both 7 units away from 5. Right? 5 is 5 units from 0, but we have to move in the negative direction to get there. So that's where we got the x minus 5 from. Take the absolute value of that because that's the distance we are concerned about, and that distance is 7. Now we can check our answer here. 12, let's plug in 12. Absolute value of 12 minus 5, is that equal to 7? Yeah, that's going to be positive 7. That's equal to 7. The absolute value of, instead of x, we plug in a -2. -2 minus 5, is that equal to 7? Well, that's going to be the absolute value of -7, which is, in fact, equal to 7. So it checks out. Again, this was something we saw last week. All right, so let's scroll down. I got another problem that's similar to that. And then we'll get to the word problems. Oh, excuse me. Second one here says, write an absolute value equation representing all the numbers that are 3 units away from -9. So I recommend you pause the video now and work this out yourself. Okay, hopefully you have paused the video and worked this out. So here I go now. Write an absolute value equation representing all the numbers that are 3 units away from -9. So we are concerned with the number -9. Do you have to draw a number line here? I think it really helps to get a visual of what's going on. So 3 units away from -9. Well, what's 3 units to the right here? It's going to be what? -6. What's 3 units to the left? It's -12. Again, this is going to be an equation. -6 is 3 units away. -12 is 3 units away. Now, remember, the absolute value definition is how far a number is from 0. How far a number is from 0. So we're worried about these numbers that are a distance from -9. So to go from -9 to 0, let's say 0 is here. How far do you have to go? You got to go 9. Is that in the positive direction or the negative direction? That's the positive direction. That's the negative direction. We have to go in the positive direction to adjust this to 0. So it's going to be this. The absolute value of x, we had to move 9 to the right, so plus 9, right? 9 in the positive direction. And our distance is what? 3 units away. So there's the absolute value equation representing all the numbers that are 3 units away from -9. We can check it out here. -6, plug that in, the absolute value of -6 plus 9, is that equal to 3? Well, this becomes 3, and that is in fact equal to 3. The other one, the absolute value of, instead of x, we plug in -12. -12 plus 9. And that gives us, should give us 3, right? I just plugged into this equation here. This is the absolute value of -3, which is equal to 3. So that checks out as well. All right, now on to the word problems themselves. We're going to work number 1 together. Scale accuracy. To test the accuracy of an industrial scale to be 1/100th of a pound, an object that is known to be 100 pounds is placed on the scale. So ideally, what does this weigh? Like we don't want it to be off too much. What is the perfect weight here? 100 pounds exactly. That's the perfect weight. That's what we're shooting for. And we're allowed to be within 1/100th of a pound. So let's keep reading. So to test the accuracy of an industrial scale to 1/100th of a pound, an object that is known to be 100 pounds is placed on the scale. Write an absolute value inequality. Okay, so now it's an absolute value inequality that shows the measured weight of the object if the scale is not within accuracy standards. So there's a key word here, not within accuracy standards. And we're supposed to solve that inequality as well. Okay, I'm not going to actually solve the inequality. I'm assuming you know how to do that at this point, but I will, we'll see. First off, if we're allowed to be within 1/100th of a pound and 100 is the ideal weight, how big can this possibly be? Well, it can be 100 plus 0.01, so it can be as big as 100 and 1/10. That's like the high end that we want the scale to be accurate to, right? So it can be off by 1/100th of a pound. Now, how about the low end? How low can we go? 100 minus 0.01, which is 99.99. 99.99. So low end, high end. So let's take a look here. The low end is 99.99. It is allowed to be that, so less than or equal to x, less than or equal to 100.01. Let's put this on a number line. We're going to have to zoom in a bit here. All right, so this is going to be 100.01. This is going to be 99.99. And we're allowed to be anywhere in between. Am I going to color in these circles? Yes, I do. So this is a closed interval here, closed interval there. Now, think about what's exactly halfway in between these two. What is exactly halfway in between 99.99 and 100.01? It is 100 exactly. Okay, so we're going to put that exact halfway point there too. We want everything in between here. So now we have a nice visual for that. Now, think back to the last problem. We are concerned about numbers that are within 1/100th of 100. So how do we take 100 and move it back to 0? We want to move that way, which is the negative direction. And how far to the left do we have to go to move 100 back to 0? We've got to go 100 to the left. So it's going to be this. X minus 100. Okay? Now, if I move 100 to the left 100, I'm also going to move 100.01 to the left 100, which would be what? If I take this number to the left 100 units, that's going to be at 0.01. And if I take 99.99 to the left 100 units, I'm going to be at negative 0.01. Okay? And now we have an absolute value inequality like you had been working before. This is the high end, this is the low end, so we can say the absolute value of x minus 100 is less than or equal to 0.01. This last part here was what was we covered it late in the week last week. So from here to here, that is not new. Okay. So there you go. Just to recap this one more time, I find the highest possible value I can have. I find the lowest possible value I can have. Oh, wait, we've got one more problem here. We want to know what is not within the accuracy standards. I found what was within the accuracy standards. So what is not within the accuracy standards? So think about that for a moment. There's a couple ways to go about this. Perhaps you're able to look at this inequality, this absolute value inequality, and just know it's going to be the absolute value of x minus 100 is greater than, is it going to be greater than or greater than equal to? Remember, it's going to be like kind of the opposite of this. Well, if this is or equal to, this just has to be greater than, right? Because it has to be different. It has to be everything that is not in the solution set. So 0.01. So perhaps you can just look and know that's what it is. Or perhaps you can say, well, what is kind of the opposite of x minus 100 is less than or equal to 0.01? It would be x minus 100 is greater than 0.01. Now this is and, right? So what we want is not and, we want or. So it would be or, and our other inequality is going to be kind of the opposite of this portion here, which is going to be x minus 100. Instead of the x minus 100 portion being larger than negative 0.01, it's now going to be less than negative 0.01. And again, it is not less than or equal to because the equal portion is taken up within the and within the intersection inequality. So I know that's a little tricky, but this would represent, excuse me, what is not allowed. What was the exact wording of the problem? Write an absolute value inequality that shows the measured weight of the object if the scale is not within accuracy standards. So if the scale is measuring anywhere in these two inequalities, which as a absolute value inequality is going to be that, it would not be within the accuracy standards. There you go. So if you were within the accuracy standards, it'd be this top inequality I found first. If you were not within the accuracy standards, it'd be this bottom inequality I found second. So, no, that's not easy. You kids are hard workers. You're smart. You can do it. Figure it out. Let me know if you have any questions. Thanks.